Hello and welcome to SudoKanard. This puzzle was published by ZegreS, not sure how to pronounce the name, on Logic Masters Deutschland very recently. It's called Two Strings and it mixes two standard rules. One of them is the arrow rules. This digit is the sum of those along the arrow. This digit is the sum of those two, and so on. So this digit is the sum of those three. It's also the sum of those three. It's also the sum of this one alone, meaning that those are three identical digits. And those here are palindromes, which means that this is the same as that, this is the same as that, and something similar happens here. So these are very common rules, and you can see that the puzzle has a very high amount of symmetry, and it also has a very high amount of praise. On Logic Masters Deutschland, with 25 solvers, it has a rating of satisfaction of 96%, which is a lot. And it has a difficulty of 4 stars out of 5, so we'll see if I manage to solve it. I actually did try it a first time, not on video, and I went pretty far, but then I must have made a mistake because it broke. So where do we begin? Something interesting is to note that the 4 digits here are cloned somewhere, and I thought I would just give them colors. Let's say this is green, this is purple, then this will be orange, and this will be blues. Blue, that's correct. Then I just clone them like this. And I thought I would use, no, not that, yellow for this one. And this one is also cloned by those arrows. And that's just a start. You see that yellow is not in any of those cells, and yellow is different from green and purple, so in this box yellow must be here. And something else is that those 2 digits here must appear somewhere on the 5th row, and it can only be here. So let's note it like this. I'm using Sudoku, which is the software used in cracking the cryptic videos, of course. So I'm using very similar notations. And by symmetry, you can see that the same is happening here. In this column, yellow can only be here. And orange and blue in this column must be here. So orange and blue, I've used those 2 colors. And we're in a situation that is frequently called roping, which means that this rope of 3 digits is also reproduced here and there, and the same happens here with this, and that. And similarly, those 3 digits are different from those 3 and those 3, so they must appear here, and similarly they must appear here, and likewise this is different from all of this, so those 3 digits must appear here, and then also must appear in those 3 cells. So the next place of interest seems to be the yellow digit, because it's the sum of 3 digits here and 3 digits there, and because of the roping, we should see that the digits that are here appear here and they appear there. So those 3 digits are the same as those ones, and by symmetry, those 3 digits appear here and there. So the digit that is here must appear in both this and that, and the converse is true. Knowing that those 3 digits are those 3 digits, and those 3 digits are those 3 digits, we see that all 6 digits that appear here must be those 5 digits. So we have 5 different digits for 6 cells, so only 1 digit is common from this to that. So this is the common digit, and that's interesting because a sum of 3 digits can only be, of 3 different digits, can only be 6, 7, 8, or 9, but 6 would mean that those are 1, 2, and 3, and those are 1, 2, and 3. And with what I say, that's only 3 different digits, so that will never work. And what did I do? If I try to make this a 7, the same logic applies. This must be 1, 2, and 4, this must be 1, 2, and 4, and that's only 3 different digits. So 7 has to be excluded as well. If I try to put 8 in here, there are 3 decompositions of 8 as the sum of 2 digits. One of them is 1, 3, 4, the other is 1, 2, 5, which means that the common digit is a 1. So 1 must go here, but 1 should then be the sum of those 2 digits, which is forbidden, which is impossible. So 8 is not the sum here either. So this has to be a 9. And I can put, oops, sorry about that, I can put 9 in all of those cells. So that's something to begin with. And now, what are the decompositions of 9 as the sum of 3 digits? One of them is 1, 2, 6, one of them is 1, 3, 5, and the third one is 2, 3, 4. So if I try to choose this decomposition and this one, then the common digit will be a 1, I'll have to put a 1 here, and the same issue will happen. If I choose this one and this one, then the common digit is a 2, I must put a 2 into this cell, and the same phenomenon happens. 2 can't be the sum of 2 different digits. So the only option is to have those decompositions, not this one, and the common digit then is a 3, so 3 goes here, which means that those are 1 and 2. And so at this point, I just know there is a 3 somewhere here, and a 3 somewhere there. And by grouping, there's a 3 somewhere here and a 3 somewhere there. I have to see how the other digits are, well, how those are chosen from 1, 2, 4, and 5. And actually, we know that the other 2 digits here are reproduced here and there. So those digits are 2 digits from 1, 2, 4, and 9, and more precisely 2 digits that sum to 6. There must be 1 and 5 or 2 and 4. And the same logic happens with this, which is the same as this and the same as this. So those 2 digits must also be from 1, 2, and 4, 5, and they must sum to 4. To 6, sorry about that. And those 3 digits must be 6, 7, and 8 in some order. And we can see that's now blue is from 1, 2, 4, 5, orange is from 6, 7, 8, and similarly green is from 6, 7, 8, and purple from 1, 2, 4, 5. Lots of options for those. I won't pencil mark the whole lot. All right. Where is the next place to look? I think this box is interesting because those digits here, those 4 digits that are on the arrows, have a minimum value of 3 plus 4 plus 5 plus 6, which is 18, but they have a maximum value of 9 plus 9, which is 18 as well. So when the minimum is equal to the maximum, that's the only possible value. So this is a 9, and those 4 digits are on some arrow 3 plus 6 and on the other arrow 4 plus 5, and I just understood the mistake that I made when I tried to solve the puzzle earlier. just understand what it was. The remaining 2 digits in the box are 7 and 8. And then, what do we do next? I just don't remember what I had done next. I think I should address the question of how to dispatch those 2 digits onto those cells. Now, it only makes sense that the sum of those 2 digits should be the higher digits, but 5 could be the sum of 2 digits. It could be 1 plus 4. But actually, this wouldn't work, because then those digits would be 2 and 5, and as we mentioned earlier, those 2 digits must sum to 6, not 7. So that wouldn't work. If I try to make this a 4, then those must be 1 and 3, and this is contradicted by this 3. So, and 1 and 2 are obviously impossible. So this is indeed the higher digit, and this is the smaller, which means that color-wise, this is not orange, and this is not blue. What did I do? Blue is... no, this is not blue, so it must be orange. All right, sorry about that. And the same is true with this and that. Trying to put 1 and 2 will fail immediately. 4 will fail because I would need a 3, and 5 would fail for the same reason that those 2 digits must sum to 6. So this again is the higher digit, so that's green, and this is the smaller digit, so that's purple. And digit-wise, this is 6, 7, or 8, this is 1, 2, 4, or 5. Right. Next, what do we have? What about those 2 digits? Because we already have 3 small digits here, and by small I mean 1, 2, 4, or 5, we can't have 2 of them here. So only one of them can be here, and actually at least one of them must be here, because they can't be both from 6, 7, 8. The sum would be much more than this. So one of them, the 4th digit from 1, 2, 4, 5 must appear on this arrow, and the other digit must be a big digit from 6, 7, 8. So the other digit must be from 6 and 7, and this can't be a 6. Which means that 6 has to appear somewhere here, and this is not a 6. And actually, I already said so, because this is the same digit as this, of course. And the small digit here must be from 1 and 2, so the big digit must be from 6 and 7, and to get to 7 or 8, the other digit must be 1 or 2, which means that the small digit here must be from 1 and 2, and knowing that the other small digit is in here, because here we have a 1 or a 2 with a 5 or a 4, it means that this is the digit that has a sum of 6 with this one. So this is 1 or 2, and this is 4 or 5. So that's correct. And the same happens by symmetry here, meaning that on this row, and actually I can do better than that. This digit plus this one has a sum of 6, so this is 1 or 2. And as I was saying, this row must have 2 other digits from 6, 7, 8, so one of them must be here, and only one of them, together with a 2 or a 1, so this can't be a 6, and this can't be a 6, and this can't be a 6, so that's a 6. We have a 6 or 7 somewhere here, together with a 1 or a 2, and this is 4 or 5. And this is 1 or 2. And this is from 6, 7, 8, and that is also true for this digit. Right? So we can do a little better. So this is 7 or 8, and it's not green, so it's orange. And similarly, this is green. And we can wonder whether there's something more to do with those digits 7 and 8, namely about this region. Not sure about that. Oh, this region, we can see that 9 is not in, it's not in here, it's not in there. And obviously it can't be a digit on one of the arrows because this digit would have to be bigger than 9. So 9 is in one of those two cells. This sum here is not 9, it's not 7, it's not 8. So this has a maximum of 6 and a minimum of 3, as it's the sum of two digits. So this is from 2, 3, 5, and 6. And those are not 7 or 9, 7 or 8 either. So this can be 7 or 8, this can't. And actually we still need at least one digit from 7 and 8. We could have orange here, or we could have it here. That's not saying much. What about this? This digit has the same restrictions as this one, meaning that it's at most 6, at least 3. Now is the place where I erred. So one digit is from 1 and 2, and the other one is here with the other digits from 4 and 5. So green is somewhere in here, orange is somewhere in here, and green is somewhere in here. Could be there if it's a 7, could be here if it's any other digits from 6, 7, 8. So that's not interesting. What about ones? Oh, I could color this one just for the sake of coloring. 9 must appear somewhere here and somewhere there. That's not very decisive. What about 7 and 8? Well, as we can see, green is in one of those two cells. So those are from 7, 8, and 9, and one of them is green. So I pencil mark this, no, not pencil marking, I cut off this like this, I think. Oh no, sorry. I put gray, but I should put yellow. So those digits are yellow and green. And now we know that orange is not appearing here, it's not appearing here, it's not here. So orange must be here. So that's 7 or 8. And we can deduce from that that orange appears somewhere here. It could be here, 7, 8 with a 1 here. That's a possibility. What about green? Green, oh, that's interesting. That's very interesting indeed. So we know that green appears somewhere here. Oh, first I put orange into this cell. Yes, orange is excluded from all of these and this and this. So orange is here. This is 7 or 8. Right. So what I was saying is that green must appear somewhere in here. That's, oh no, green could be here. I must be careful. I know that orange must be somewhere in here. Orange must appear somewhere here, but there again, it could be on the arrow, in which case that's a 7. Green is 8 and there's a 1 somewhere, but it could be here. Perhaps I should pay more attention to digit 6. So we have a 6 here. We know that 6 appears in one of those two cells. 6 is somewhere up here. Somewhere in here. We don't know much about 6. Somewhere here. It could be to this cell or somewhere else. Perhaps I should focus more on those 1 and 2 digits. So what about 1 and 2 on this column? For example, this 1 or 2 is located on this arrow. But this 1 and 2 is on this arrow. But this 1 and 2 is somewhere in here. Or perhaps I should ask what this can be. So this is at least 5. Because I need to have it as 2 different sums. But can it be a 5? If this is a 5, then it means that all digits here are from 1, 2, 3, 4. And for some reason, this is something I excluded earlier in my previous attempt. I just don't know why. I'm not seeing why I chose to rule this out. I don't see any real argument to support this. The plot thickens. Oh, that's more interesting. Where is 6 in this column? 6 is not here, it's not big enough for this sum. 6 is not here because of that, so 6 is in one of those 2 cells, so neither of those is a 6. And because 9 is the sum of 6 and 3, we can deduce that this is never a 3. This is never a 3. A 3 here would put a 6 there. A 3 here would put a 6 there. And here we get a 3, 4, 5 triple. So there's no 3 in here. 3 is definitely in there. 3 is in here. So 3, 4, 5 triple. That's interesting. It means that most digits on the remainder of the row must be big. There's a 1 or 2, and the rest is from 6, 7, 8, and 9. And this digit is neither orange nor green, and it's not a 6, it's not a 9, it's not a 6. It has to be 1 or 2. Oh, that's interesting. This I had missed on my previous attempt. So this is from 6, 7, and 8. And this is also from 6, 7, and 8. This is from 6, 7, 8, and 9, but that's too much to pencil mark. But now, on this column, we have the 1, 2 pair, and we still need 3, 4, 5. All right, and we have the 3, 4, 5 triple in here. So we need the second 1 or 2 in here. And the third 6, 7, 8. All right. And I'm tempted to color the 1 and 2s, but that's a bit too much. I think I will use similar colors for the 4 or 5 that goes with the 1 or 2 with a sum of 6. So I think I use purple for this and blue for this one. So this is the purple 1 or 2, that's the blue one, and that's the purple. And that's interesting because this can't be 1 or 2 anymore. The blue 1 or 2 on this row must be here or here. And this is never 1 or 2. And you note that we have a 4, 5, 6 triple on this column and a 7, 8, 9. So the remaining 3 digits here, here, and there must be 1, 2, 3. This is neither blue or purple, so it has to be a 3. And the purple 1 or 2 must be here. I generally don't do the puzzles with coloring, but I don't quite like it. But I'm really enjoying this one, I must say. So we know that the blue 4 or 5 is somewhere in here, that the purple 4 or 5 is somewhere in here. Let's say that's something. So the purple 1 or 2 is not here, so it must be here. And it pushes the 6 into this cell. Oh, sorry about that. So this one is the purple 1 or 2. Let's move back to digits. So that's the 6. And what else can we do? So the purple 1 or 2 must be somewhere in here. Together with the the orange could be here. That could be the 6. I must pay attention to that. It's a mistake I must refrain from doing. So now 6 is somewhere in here. We will know that already. What could this be? Maximum of 5. 1, 5, and 6 would work. There's truly some more work to be done. So the blue 1 or 2 is somewhere in here. In this box, we don't know where the blue 1 or 2 is. Could be here with a 3 here. Could be here, could be here. I have no clue. So here we have the blues with the 3. So those 2 digits. Yes, here with the 3 we have those 2 digits. And here we have those 3 digits. That's correct. So we have the green somewhere in here, and the blue 1 or 2 here or here, and the 6. Now, having this 6 was quite an interesting step. We have the 2 blues here. I can kind of pencil mark them. And 1 of each in here. I'm not seeing what I could do with this. So the purple 1 or 2 is somewhere in here. The purple 4 or 5 is somewhere in here. This is all very confusing. Is there more I can do with digit 6? Could I really have 1, 2, and 3 in here? I can't see any reason why. No double negative from me. We don't need no education. Meaning, we do need education. There's no need for lack of education. Oh. This is really, really becoming tricky. An interesting point is that this is neither 7 or 8. And this is also neither 7 or 8. That doesn't seem so interesting, actually. And let's recall that the only clues that break the symmetry are this arrow and this arrow. And at this point, I really don't know what to do with them. Placing this 6, or this 6 sort of, is a really nice step. So is there more I can do about that? I'm really not seeing what. So I've paused the video a little moment and I was thinking, one of these arrows has the purple 1 or 2, and this here has the blue 1 or 2. So one of them has the digit 2, and the one that has the digit 2 has to be 2 plus 6 equals 8. So here I have 2 6 with 8 and 7, or here I have 2 and 6 with 8 and 7. So what does this tell me? Now that much, but one of these two is not a 6. And 6 comes with the 8. Whatever digit here is an 8. So it comes with a 6 in here and a 2. So 8 is with a 2. Let's imagine this is 8 with 2 and 6. Then it means that this is a 4. So 8 comes with a 4. And 7 comes with a 5. So this domino has a sum of 12. Same with this. This domino also has a sum of 12. Now, is it useful? This I don't know. But I found it quite interesting. And now I'm thinking, if I have a reason to suspect that I have, let's say, green, what have I done? Let's say green here and purple there, green I said, then there could never be 8 and 4 because it would repeat the 4. It would be 7, 5, and 2. But I have absolutely no reason whatsoever, and actually this green for this would really never work. But let's say orange here, that is compatible with what I was saying, and blue here. So they wouldn't be 8 and 4, because 8 and 4 would need a repeated 4 in here. But as I was saying, there's absolutely no reason to decide that they are in such a position. Or maybe there is a reason to think it is so, but I haven't found it yet. So what about this orange digit? Where is it? And I really don't know. I'll pause the video again. Well, I just found what I was supposed to find, I think. So, as I was saying, if this is 8, then those must be 2 and 6. Well, definitely, and that's a 7. But then this must be a 7. And the only way to have 7 is to have 1 plus 6. So what I'm just saying is that well, more precisely, wherever there is a 2, it's with an 8, so the other digit is a 6, and then the other digit is a 7, and it's 1 plus 6. So in other words, wherever I put the 7 and the 8, I must have the 6 here. I must have the 6 here. So that's not a 6, and that's not a 6. So this is where orange is, and this is where green is. And those are from 1, 2, and 6. And those also are from 1, 2, and 6. And this one or 2 is the purple one, and this one or 2 is the blue one. And that's pretty interesting, because now we know that green is in none of those cells, and orange is in none of those cells. Now, can they be on the arrow cells? Well, if that's the case, then this must be bigger than that digit. But this can't be either 7, 8, or 9. So this is at most 6. And actually it can only be 5 or 6. 5 with 1, 4, and 2, 3 in some order, or 6 with 1, 5, and 4, 2 in some order. So 7 and 8 can't be in any of those cells. Because of that, they can't appear here. So they must be in the remaining 3 cells here. And more precisely, orange can only be here. And green could be here, could be here. So there the symmetry is broken. So that's a 7 or 8, and that's the orange one. And the green one is in one of 2 places. And we can deduce that in this box, orange can only be here, which means that 9 is here. And that's orange. But now that we know that 9 is here, this is 9. And this is 9, which means that this is not a 9. But this is green. I can remove this coloring. I can color this in and this one as well. So all knights have been put into the grid, and now green can only be here. Yes, that's it. So green is not here, it's not here, it's not here, green is here. So that's a lot of coloring. And this now is not 7 or 8, so it's a 6. That's not a 6, and actually it's so much not a 6 that this is green. And then I think we've located all 7s and 8s. And this 6 is interesting because this now is a pretty small sum. The digits between 1 and 4. So that's, because of this 6, that's not a 6 anymore, that's a 5. And this is not 5. So that 6 can only be here. So we remove 6 from there. And this is actually purple. That's the purple 1 or 2. And that's the 6. And because of this 6, we can also remove 6 from the options of this cell, and this is the blue 1 or 2. And that's the 6. And now by Sudoku we get a 6 here, which means that this is 4 or 5, and more precisely, the sum being 6, this is the purple one. And because of this 5, we know that this is a 4. And now this should be the turning point. So we can put 4 into all those cells. Correspondingly, we can put 2s into all those cells. We couldn't put 1s into those. And 5s into those. So no 5 here. And here we have a 1 and a 6. We're getting there. 6 plus 1 is a 7, so orange is 7. And green is 8. So a lot is happening. Now, because of this 4, we don't have a 4 in here, and we don't have a 5 in here. What did I do? We don't have a 5 in here, and because of this 4, that's a 3, that's a 4. Here I need 1 and 5. Well, obviously 1 and 5 are blue. This is 1, 3, and 5. This is 2, 3, and 4, so that's a 3. We need 2 and 4 in there. That's a 1. So that's a 4 to have a sum of 5. So that's a 2, that's a 3. What have I done? That's a 4. That's a 3, that's a 2. So this can only be a 1. We're getting there. Here we need a 1, and that results in the 1, 5 pair. This now can only be a 3, and that's a 5. Up there, this is 3 or 5. And we get a 3, 4, 5 triple in here. A 5 would never work here, it's too big for this sum. So that's a 3, that's a 4, that's a 5, and that's a 2. So that's a 1, that's the 6. 5 here, 3, 6. This 5 here puts a 3 here and a 5 there, and we're left with a 1 and a 4, and that's it. The solution is correct, 51 minutes, and that's counting the minutes I spent in a pause. So that was a very, very cleverly designed puzzle. The kind you see all the time on Cracking the Cryptic, and obviously my content is quite different because I usually tend to focus on contest puzzles, and this is much too hard for a contest, obviously. But from time to time, I like to test myself on those to see that I also can solve them. And I really had a good time in spite of the coloring. So thanks for watching this video, and see you soon with probably more usual content on SudoKanard.